Okay, so I have an animation here. I'm going to just set it going here. And I want you to talk about what you're seeing. And based on what we're talking about, what is this about? There we go. Now it's picking up. Okay, let's hear your thoughts. What do you think?
Oh, yeah.
Gavin?
We said it's integrated from top to bottom and then from left to right. So that would be a double integral with the dy dx.
He's saying, so what would you say again?
I said it's starting off integrating from top to bottom. Well, I mean, it looks like the line, that's what it's doing. I don't know.
Which is the top function?
The red function.
Okay.
And the bottom function is the blue function.
So from
Bottom to top.
bottom, right? Bottom to top, right? Bottom
Did
to
I
top.
say top to bottom?
Yeah.
Oh, I'm sorry. In my head, I was
You were thinking the right thing.
bottom
Okay,
to
you're
top.
thinking the right thing. Okay, so that's bottom to top, and so that is for a given what? So fixed what?
Fixed x.
Fixed x. So that's integrating with respect to y, and then those things what? So those things then we're going to go from left to right. So this is an illustration of what in general? Which kind? Yeah. Is it both? Is it type 1 and type 2? The first part's type 1 and the second part's type 2? Type 1. This is all type 1. This is exactly how we think about a type 1 integral. We fix x and we integrate with respect to y for a typical x, and then we integrate with respect to x, right? We accumulate all those strips that we made at a given x, right? So this is showing a type 1. So this is what, when you're setting up a type 1 double integral, this is what's your image of it, right? Okay, and so then let's just review here. So that's like this, right? Type 1 is bottom function to top function, and then left value to right value. Or we'll just for short, bottom to top, left to right, dy dx. Okay, and that's the bottom to top. And then I showed you the accumulation of those things, those black strips, from left to right. It's the outside integral. Okay, and then type 2 would be what? What would be our mantra for type 2? Left to right. Bottom to top, right? Left function to right function, and then bottom value to top value. Or left to right, bottom to top, that's dx dy. So you can you imagine this if I were to make an animation of that? Explain to the person next to you, what would that animation look like that would show this type 2 approach? So everyone's talking to somebody. Okay, what would happen first? What would be first? Ben.
It would essentially go across.
Okay. At what value of y?
That would be at C.
At c?
Yeah.
So it's really that would be the first one, but really so it's like any, right? So it's like any. It's kind of a trick question. So yeah, so it was going to go from left to right at any arbitrary what? Y value, right? Left to right at any arbitrary y. And then what are we going to do? Take those and accumulate all of those strips from. So you can imagine this thing like if you were pouring water in, it would be filling up like you poured water into that thing, filling up from bottom to top. Okay, questions on this, our overall approach to type 1 and type 2. Okay, so I was going to make the next slide was going to be just in really big letters. These are geometry problems. You need to make a picture. How many times have I had students come in for help on these, and they want to do double integrals, and they never draw a picture of the region? These are geometry problems. You have to draw a picture of the region. Do you feel my emotion? Make a picture, okay? Especially with the ones we're about to do here. So especially when you're given it in one order, and you're asked to change the order. It's absolutely essential that you draw the picture first. And then what you do is then you throw away the integral you're given. Once you have the right picture and you have the right functions labeled on that picture, then you can just like disregard the integral you were given and start over and then do it in the other order based on your picture. These are geometry problems. They're geometry problems, okay? So the first two are easy and then the next two are a little bit harder. So you're going to work on these. Number 2 is okay, I hope. I think we can bypass that one. Number 3. Let's just write down the answer to number 2. See if you guys can all check. Make sure you're good. Answer to number 2 is... Julian, what'd you get?
I got a double integral from 0 to 6.
0 to 6?
From 0 to x.
Oh, 0 6 on the side, right? 0 6?
Yeah, sorry, 0 to 6.
And 0 to...
Root x. That's why I do like x. I'm not sure.
Okay, that's been proposed. What do you guys think? People are nodding. You got it. All right, so that's number 2. We won't go through it, but, right, so I've skipped all the work, right? I've skipped all the work, which is making the picture and getting it from the picture. Okay, so here's this next one. I've graphed these 2 lines. So 0 to x plus 1, this is y equals 0. Are you guys done with number 3, or are you still working on it? Okay, keep working, and I'll keep working on number 3. Yeah.
Would that be the integral from 2? Because I thought the x would go from like the square root of x.
So y squared to 6, and then 0 to square root of 6 is this here.
The integrated is.
So then 0 to square root of x, 0 to 6, I think it's right.
It's going. The integration is from the y squared to 6, not 0 to y squared, which is.
Right, this way. But that's dx, right? So it's from y squared to 6.
Gotcha.
You see, because it's left to right.
Okay.
So yeah, you're right. If that was at the bottom to top, it would be this thing up here, but it's left to right. Okay, so this is how you should be conceiving what's given. Is that, did you get that picture? That's the picture. And it's the, so what is it? It's this whole thing, right? So from 2, x equals 2, all the way to x equals what, 14. And then from 2 to 4, the top is x plus 1. Then from 4 to 14, the top is this other function. So it's, whoa, got away from me there. So this is, this weird looking trapezoidal thing is the region, which I'm having a very tough time outlining. Wow, really bad. Sometimes you got it, sometimes you don't. Okay. So it's that whole thing. That's the region. If this thing is all one region, D, it's this weird looking wedge, okay? The red and the blue together. Okay, so now we know what these are. This is y equals x plus 1. This is y equals negative 1 half x plus 7. And this is 2. Y equals 0, and then 14. So now we can just, oh, I should have wrote that down later. Okay, but anyway, so now we've got that thing, and we can just forget about these limits and just look at the picture, and we say we're going to write it as type what?
2.
Type 2. And so oftentimes you'll have to split it up in one type, and then when you twist it to the other type, you can write it as one double integral. Is that the case here?
No.
Sarah, is there a question? Yeah. All right. Better? Better. Okay. Next. Okay, so now we're going to do this type 2. So, one double integral or more than one? More than one because of? Because of the bottom, the left side, the top, or the right side? The left side is the problem, right? Because now we're going to come and do dx first, and there's 2 parts to the left side, which means we have to split this up, right? There's part of it for these y values down here. The left side is 2, and for this part over here, the left side is what? So this is also x equals y minus 1. And this is also x equals negative 2 times y minus 7. Is that right?
14.
What's that?
Oh.
Yeah, I'm in parentheses still. Okay. All right. So here we go. So then we're gonna do what? Left to right first. And for part of that, that's from 0 to. So we need this point right here. What's that point right there? 2, 3. Is that right? So y equals 3 is our dividing line. So when y is going from 0 to 3, our left side is x equals 2. And then the right side, between y equals 0 and 3, the right side is negative 2 y plus 14. If you want to make that easier. And that's when x goes from, when y goes from 0 up to 3. So now here's where we have to split this now. Splitting that right here. Okay, so we go from 0, so we go from 2 to negative 2y plus 14 as y goes from 0 to 3. And that's what, dx dy. And then, now up here, as y goes from, what, 3 to, is that 5? So you have to solve these equations simultaneously to get the y value. So as y goes from 3 to 5, x is going from y minus 1 to the same thing again, right? On the right side, it's the same boundary over here. So negative 2y plus 14. All right, questions on this example? So when we went from type 2, left to right, bottom to top, we first had to do this part, and then we had to do this part. So I talked a lot. Does everyone follow it? Anyone have it before I question?
Should I, I don't know, I probably made this more difficult, but I split it up into 3 integrals because I did that big blue triangle as one, and then I did split the red part into a little triangle, so I did
So you went from here to here.
no.
So as you went from left to right, you did that line to that one, and then you did those two.
Yeah.
That's what I did.
It's okay, but so you're doing 3 instead of 2 then. But you see how you can do it in 2. So the important thing is you recognize that it can be done in 2, and that would be preferred. But yes, breaking it up into 3 pieces, as long as you have all your borders right, you'll get the same thing in the end. But yeah, so just recognize that the only thing that we needed to split it up for was the left side, and that just required 2. The whole right side is fine. Yeah?
Are we just use the big triangle minus the small triangle?
Big minus the small. I think so. So you're going to go, so you want to do this whole big triangle, so you went all the way from here, from negative 1 over to here, or this over to here, and then you subtracted that? I think so. I think that's okay. Yeah, you could do that. Other questions? Okay, how did this last one go?
Is it like a piece of circle?
So yeah, we got to know what these things are. So take these. What is x equals radical 25 minus y squared?
It's like a piece of a circle. That circle is 7x, 0, minus 5.
And then 1/2 y. Yeah, so if we're expected to know about spheres and change all those around, then circles should be a breeze, right? So you should recognize this is a circle, right? If you squared both sides, you'd have x squared plus y squared equals 25. And that's a circle radius 5. So this is just which part of that circle is it if we have x equals radical? Top?
Positive x.
X is positive, so it would be the right side, right? So this would be the right half of the circle radius 5 center. Okay? So we got that. And so now we got to figure out which part is it. So this is what, type 1 or 2? 2, our mantra is left to right, bottom to top. So the left side is the line, and the right side is the circle. As y goes from 0 to 2 radical 5. And is that the intersection of here? So 2 radical 5, I'm thinking maybe that's the intersection. But it could be some number down here too. Okay, so don't just assume that. 2 radical 5 could be any y value through here. But I'm guessing that it is that intersection. And it is. If you solve those simultaneously, their intersection would be whatever that x is and then 2 radical 5. So left side, right side means, and then 0 to 2 radical 5 means we're talking about this. Okay, and we want to switch it to a. So this is x equals radical 25 minus y squared. And so what is that in terms of y equals x? If you do the math, you get the exact same thing. Yeah, if you do the math, it works out, you get the same thing. And this is x equals 1/2 y means y equals 2x. So now, what's our type 1 going to be like? What's it going to be like? One integral? We do one integral for type 1? 2, because of the top, right? The top changes. As we're going from left to right at x, the top is the line, and then at some x value, then the top becomes the circle. So the bottom's always 0, but here the top is the line. Over here, the top is the circle. So we need to split it. So what's the x coordinate at this point? Oh, no. The x coordinate. Square root of 5? Square root of 5 and 2 radical 5. Right there. Okay, so we're going to go, so when x goes from 0 to 2 radical 5, our bottom is?
It's just root 5.
Thank you. Yeah, that's x. Yeah, so as x goes from 0 to square root of 5, thank you, our bottom is? 0, and the top is y equals 2x. So now we're doing dy dx, right? And then now our x goes from radical 5 to 5. And that from, I got one little more thing to show you after this, so don't. 0 to square root of 25 minus x squared. Questions on this example? Okay, one more little idea to share with you, and then we'll be done. Questions on any of these examples? Last chance. Okay. What's that? So because y went from 0 to radical 5, this is a boundary of it. So that's the boundary right there. Yep. Okay. Other questions on this example? Last chance. Okay. So I want to talk about double integrals find what again? Volume? Not volume. Signed volume, right? Difference of volumes, okay? So here I've got this region D and some surface over it. Okay, the double integral of f over d computes the signed volume of the solid formed between f and the xy plane within the vertical cylinder defined by d, right? So d defines a vertical cylinder, and then we look at the signed volume between the xy plane and wherever the surface is. You still with me, Julian? Okay. All right. So that we've talked about. So what would it be like? Could we talk about using a double integral then to find area? Could we use a double integral to find area? We know its meaning is signed volume, but could we use a double integral to find area? And so what about if we took, so there's our solid. Okay. So what if we took some positive function, z equals k? Then what would the double integral find? If we took some positive function, z equals k, what would the double integral find?
Area of d times k.
So it would be a volume, right? This wouldn't be signed volume anymore. If it was a positive value k, we would get it would be the volume of the cylinder, right? It's the volume of a right cylinder, defined by d. Okay? And so what is that? That's the area of the base times the height, or the area of d times k. you see that? So it's the area of D times K, or the height of it, would give the volume, and that would be the value of the double integral, right? So how could we then make this thing, this double integral, calculate the area of D for us? What should we do? No, don't, you're not dividing, then you'd have that double integral over K. So we want the double integral to give us the area. We want the double integral to give us the area. Make not really small. What should K be? So the double integral equals the area. 1, right? So if we want the double integral, if the area to be the double integral, then we want this constant function to be the function 1. If K equals 1. And so then, and that's to say that the function, whatever this function that our rate function, right? The function that we're integrating, if we make that the function 1, then we get the volume of the cylinder with height 1, which has the same value as the area of the base. You see that? So if we make the function f1, then the double integral of just dA, just 1 times dA, not only is the volume of the cylinder of height 1, but it has the same value as the area of the base. So this is a way we kind of trick a double integral into giving us area for us, calculating the area of an R2 region by making that function equal to 1. That's a really important concept. Okay, web work over break. Have a good one. Be safe. Have fun.